Level 0. The sky is quiet. Clouds drift. Airplanes draw white lines. Birds soar. The sun warms your skin, and night brings only stars. Everything feels still, predictable. But that's the illusion, because above that blue dome, the sky is alive, a canvas of electricity, ice, magnetism, and light, waiting for the right moment to break the rules. This is level 0, where calm skies conceal their capacity for wonder, and just beneath that calm, the storm of color begins. Cities now use sky pollution sensors and dark sky ordinances to preserve visibility of natural phenomena, protecting the night not just for us, but for discovery. Level 1. It starts with a glimmer. Not lightning, not thunder, just a vertical shaft of light stretching from the ground to the clouds. Or is it coming from the clouds to the ground? You're seeing a light pillar, not a beam, but a reflection. When temperatures drop low enough, flat ice crystals form in the air. They float, spin, and align horizontally. Then city lights, moonlight, even a car's headlight catches them. And a vertical glow seems to rise into the sky. They aren't physical columns. You can't touch them. They don't heat, they don't burn, but they stop you in your tracks, as if someone drew a line from earth to heaven. Light pillars often appear in polar regions and during cold winters in cities like Moscow or Minneapolis. Reducing urban light pollution allows these natural illusions to shine clearer and be documented for weather research. Level 2. The sky flashes, but the storm is miles away. And this lightning isn't normal. It leaps from the top of a thunderstorm, not down, but up. This is an upward lightning discharge, a phenomenon where a positive bolt shoots from a tall structure, like a tower or wind turbine, straight into the cloud. It can stretch kilometers. It's rarer than cloud-to-ground lightning, and more powerful. Sometimes it occurs without rain, just static buildup, tall metal, and a little atmospheric instability. It's not seen often, but when it hits, it glows like Zeus waking up. Lightning protection systems on skyscrapers and turbines now factor in upward discharges. Advanced sensors help model atmospheric charge conditions and reduce lightning strike risks for aircraft and infrastructure. Level 3. A cloud grows in silence, high, wide, dense, and then a spike of blue fires out from the top. It's a blue jet, a narrow bolt of lightning that shoots upward into the stratosphere. Not white, not yellow, electric blue. They rise tens of kilometers above the storm, piercing air that's nearly vacuum. You won't see it from the ground, but satellites and high-altitude planes do. It lasts less than a second, and yet in that moment, it punches energy upward into a layer of atmosphere that shouldn't glow, but it does. Because blue jets don't obey, they erupt. Recent research from the International Space Station recorded blue jets over tropical storms, helping scientists link them to intense charge imbalances and improve aviation safety over thunderclouds. Level 4. The lightning bolt has a twin, but it lives in space. It's not a bolt, it's a pulse, a radiant flash that mimics lightning but doesn't strike. This is an Elves, short for emissions of light and very low-frequency perturbations due to electromagnetic pulse sources. It begins when a powerful lightning bolt explodes with energy. That energy radiates upward, striking the ionosphere, 80 kilometers high, and then, for less than a millisecond, a giant red disk blooms like a jellyfish, invisible to the naked eye, but captured by cameras in infrared. It's not folklore, it's not aliens, it's Earth's sky reacting in layers we barely understand. Studying Elves helps us understand upper atmosphere physics and the impact of electromagnetic energy on communication systems during strong thunderstorms. Level 5. Now we go higher, above the storm, where air is thin, and color shouldn't exist, but it does, faint and furious. This is a red sprite, a colossal flash of crimson that blooms like a tree in the sky. They're born from extremely powerful positive lightning strikes, and when that charge leaps to the ground, the ionosphere reacts. It paints a red flower above the storm, columns and tendrils, kilometers wide. They don't last, but they leave after images in infrared cameras. Sometimes pilots see them from above, dancing silently, like ghosts, too high to hear, too strange to forget. Since 1989, red sprites have been studied from aircraft and telescopes. Pilots now report sprite zones to researchers, linking them with severe weather systems and ionospheric fluctuations. Level 6. The storm has passed, but something lingers. A silver cloud, high, too high, floating where clouds shouldn't float. This is a Noctilucent cloud, made not of vapor, but of ice crystals dancing at the edge of space. They glow when the sun sets far below the horizon, catching light at impossible angles. They shimmer in blues, purples, and silvers. They appear in summer near the poles, 76 to 85 kilometers up, and they may be increasing. Some scientists believe they're tied to methane, rising emissions giving rise to ice at the mesosphere. Others think they signal climate change aloft. Whatever they are, they look like whispers from another world. Ongoing climate research monitors Noctilucent cloud frequency and altitude to track upper atmosphere temperature shifts and greenhouse gas trends. Level 7. The sun is gone, but the sky still glows. Orange, pink, violet, not on the horizon. Overhead, it's not sunset, it's afterglow, caused by volcanic aerosols, dust storms, or even wildfire smoke scattered in the stratosphere. Particles high above Earth bend and scatter the last rays of sunlight, long after the sun has disappeared from view. Sometimes afterglow can last for over an hour. In rare cases, global events like the 1991 Mount Pinatubo eruption create sunsets so vivid they alter cultures, inspire art, and confuse timekeepers. It's beauty born of disaster, a side effect of particles too small to see, doing something massive to our light. Scientists use LiDAR and satellite aerosol tracking to measure these particles, linking volcanic activity or pollution to changes in atmospheric optics and sky brightness. Level 8. The sky isn't flashing, it's pulsing, like a heartbeat. But it's not your heart, it's the sun's. You're witnessing an aurora, but not the green ripple you expect. This one is purple, crimson, even white. Auroras are born from the solar wind, streams of charged particles that collide with Earth's magnetosphere. When they hit, energy floods the upper atmosphere, and nitrogen and oxygen paint the sky. But sometimes, something weirder appears, a vertical streak. Not dancing, but standing, like a line of violet fire. It's been nicknamed STEVE, Strong Thermal Emission Velocity Enhancement. Discovered only recently, not an aurora, not quite. It's a narrow band of glowing plasma, 600 kilometers long, and hotter than the surrounding air. It appears where it shouldn't, behaves in ways we don't understand, and it's not rare. We just didn't know to look. Steve was discovered by amateur skywatchers and confirmed by NASA in 2018. Citizen science platforms now help track these phenomena in real time, giving researchers new insight into magnetospheric substorms. Level 9. It's not lightning, but it strikes. It's not cloud, but it floats. This is a ball lightning event. A glowing sphere, anywhere from the size of a golf ball to a beach ball. It floats across a room, hovers silently, then vanishes or explodes. For centuries, it was folklore. But now, there's video. In 2014, Chinese scientists accidentally recorded ball lightning during a thunderstorm. Spectral analysis confirmed it: sodium, iron, and silicon. Theories suggest microwave radiation trapped inside a plasma bubble. Others say it's quantum, maybe chemical, but no one knows for sure. Ball lightning has entered homes, floated through airplane cabins, and once reportedly passed down a chimney. Real or not, it's still classified as unexplained, and that makes it more dangerous because we can't predict what we don't understand. Power grids now include protection algorithms for rare electromagnetic surges, possibly related to ball lightning. The event remains under active study, with potential ties to nanoplasma and soil composition. Level 10. The sun isn't rising, but the sky is glowing, blood red before dawn. And it's not just color, it's motion, shifting waves of red, violet, and orange. This is a pre-sunrise airglow event, a rare occurrence when atmospheric particles charged the night before react with the breaking edge of morning. It's not reflected light, it's emitted light, caused by oxygen atoms recombining in the thermosphere, and it can be so bright it looks like a second sunrise. Not everyone sees it. You need clear skies, high altitude, and little pollution. But when it happens, it paints the sky like it remembers every charged particle from the night before. a cosmic memory, on fire. Airglow studies help us understand ionospheric temperature and density fluctuations, vital for GPS signal correction, radio communication, and tracking space weather's effect on our upper atmosphere. Level 11. The storm is below, but the sky above flashes again without warning. You're looking at a gigantic jet, a bolt of plasma that connects a thunderstorm directly to the ionosphere, 80 kilometers above. It's not a spark, it's a surge, hundreds of amps climbing through clear sky. It can stretch over 50 kilometers in less than a second, and it carries the energy of an entire lightning storm in one bolt. In 2022, a massive jet struck above Oklahoma, so powerful it was visible from space. It's not your average lightning. It's a message from the earth to the sky, a circuit closing, and sometimes it reverses. Charged particles fall down from the ionosphere, a sky striking the earth. Before we even see the clouds, gigantic jets challenge our understanding of atmospheric electricity. New satellite instruments and upward-pointing lightning detection towers help researchers analyze jet conditions to improve early warning systems. Level 12. You hear it before you see it, a low boom. Then the clouds ripple, waves form. In the sky, they curl like ocean surf, rising, breaking, folding. These are Kelvin Helmholtz clouds, caused by wind shear when two layers of air move at different speeds. Friction at the boundary creates rotation, and suddenly the sky looks like it's surfing, or rolling, or breathing. It's rare, delicate, gone in minutes, but it shows us that air, though invisible, behaves like water, turbulent, layered, capable of beauty beyond thunder and rain. Aviation meteorologists monitor for Kelvin Helmholtz formations because they signal turbulence zones. Pilots avoid these areas when reported, reducing risk during ascent or descent. Level 13. The sky hums, not with sound, but with movement, all directions at once. The stars blink, then vanish, and the sky itself seems to twist. This is an atmospheric gravity wave, not from space, but from Earth, caused by storms, mountains, jet streams. When air is pushed upward into a stable layer, it oscillates, like tossing a rock into a pond, except the waves move through the sky. You can see them in cloud bands, in satellite images, even in the aurora. They disrupt weather, they shake satellites, and sometimes they tear the atmosphere open enough to make rocket launches drift sideways. Invisible, but real, and absolutely colossal. Meteorologists use high-resolution models to predict gravity waves, which are essential to forecasting turbulence and understanding stratospheric temperature shifts. Level 14. It flickers for seconds, a spiral, a wheel, a flower blooming in reverse, not natural, not local. This is the rocket exhaust phenomenon, spirals and plasma trails caused by rocket launches venting fuel in the upper atmosphere. The particles freeze, then glow, scattering sunlight even at night. They twist, expand, morph. As the rocket leaves Earth, it leaves its signature. In 2023, a SpaceX launch created a glowing spiral over Hawaii. Residents panicked. Reports flooded in. Alien portal, black hole. The truth, just fuel, moving through vacuum, painted by sunlight. But it shows how easily the sky becomes a stage. For science, or for spectacle. As global space traffic increases, skywatchers and observatories now log scheduled launches to separate natural events from man-made optical illusions, preventing false alarms and preserving research data. We've seen the sky burn, ripple, hum, and explode. We've watched birds fall, fish vanish, storms spark upward instead of down. We've named things like Elves and Steve, and still, we barely know what we're looking at. So here's the question, what else is hiding above us? From red sprites to alien lightning, the sky is alive with phenomena most of us will never notice until someone points up and says, "What is that?" If you learned something new, tell us your favorite level in the comments. Like if you love weird science. Share this with someone who thinks the sky is boring, and subscribe for more mysteries that stretch beyond Earth but start right above it. Because the sky doesn't just end at the stars, it begins with the things we still don't understand. See you in the next video.